This is a Falcon CNC video measuring machine. The machine has a measuring range of 6 inches across the x-axis, 6 inches across the y, and 5.5 inches up and down in the z. Also, it has a zoom capability. At the bottom here we can control the collimation of a substage light, and at the top we have a camera aperture control to increase the depth of field when measuring parts which are at a irregular height in the z-axis. In the software we have the main video window, which takes up the largest area of the screen, the current stage position, which also doubles as the feature measurement window, and we have a part view window. These three windows switch around, and you'll see this as I go through the software. Over on the right we have a feature list. Across the top are the main software control items, such as go to home, report view, change magnifications, part view overlay mode, millimeters or inches, and display degrees in degrees, minutes and seconds, or degrees and decimals of a degree. I'm going to create an inspection program now to show you how to create a parts program and run that program in the M3 software. I'm going to do this using Vision Engineering's Pattern Finder probe. The Pattern Finder probe makes it very easy to quickly locate the parts on the machine and then run automatically. To do this, I've already put a part on the stage, and I'm going to locate on an area of a part right here, this keyway slot here, for the machine to recognize. To do this, I go to Datums. The last icon along to the right is Pattern Find, and I'm going to do a datum pattern find. To do a datum pattern find, I identify an area of a part I wish the software to recognize. I do this by drawing a marquee around that area. As you can see, it has now identified that area and has also datum to that area. However, this datum is not back to our part coordinate system on the blueprint, so we still need to create additional datuming to measure the part to print. So the next step in doing this is to go to datum and create a skew, a datum skew line. And to create a datum skew line, I move to the bottom of a part right here. I'm going to take points along the bottom using the touch to measure functionality in the software. And when I finish taking points, I click Done. That has completed the datum skew function and has aligned the part. The next step in this process is to create an origin point. I'm going to create an origin point in this bottom left hand corner of the part. To do this, I'm going to measure a line going down the left hand side, and when I have finished, I push Done. Now I'm going to go over to the part view window, and I'm going to make this bottom corner here my datum origin. To do this, I just simply click on Datum. It's on datum point, and I'm going to draw a marquee around the two features I wish to create a datum intersection point, and I push Done, and that has created the datum, the primary running across the bottom of the part, the secondary running along the left hand side of the part, and the origin in the bottom left hand corner of the part. Now we can measure the features in our part back to the datum coordinate system. First, I'll measure this hole. I can simply click on the hole and the software has automatically detected that I am measuring a hole and has returned a circle measurement for us. This circle measures 5.686 in the x-axis, 24.469 in the y. I can also measure a slot. To measure a slot, I click slot, take points, and push done. And that has created a slot measurement for me, length of 19 millimeters and width of 3 millimeters. I'm going to go along now and measure this bolt hole pattern. The easiest way to do this is to get as many of the holes in the field of view as possible. So here's my bolt hole pattern measured. Now the last thing I'm going to do is measure the length of the parts, and to do this I'm just going to measure a line going down the right hand side and construct a length measurement. Click done. Go into my part view, click distance measurement, click the first line and the last line and push done. And my length measurement is almost 60 millimeters. The next thing I'm going to do now is I'm going to import nominal information into my report. I can import nominals from the DXF file, or I can key in nominals as shown. I will key in the nominal right now for the distance measurements by simply clicking on the feature detail, change over to nominal. The nominal should be exactly 60. I push done. Then I'm going to tolerance the x-axis, and I'm going to key in for my tolerance 0.1 and 0.1. So my tolerance for the high and low tolerance for my x-axis is plus or minus 100 microns. And to complete that, I push done, and as you can see, this is past tolerance. Another way we can enter tolerancing is from the report view directly. In the report view, I can click enter nominals, and I can enter in nominals and tolerancing information right here for each of the features. Alternatively, as I was saying earlier, I can import my nominals from a DXF file. And as you see, it's populated my nominal information right here. Now I've populated the nominal information, and for all of the diameters I'm going to put in a standard tolerance. To do this, I simply go through my feature list, highlight all of the circles, you'll see here I have 8 features selected, and then on nominals I can key in a diameter, tolerance for, we'll put in 50 microns plus or minus, and push done. And push done. Hit done again, and all 8 of these diameters have passed tolerance. I can now click Done once more and go back to the report view. In the report view now, I can tell it to show me toleranced features only. And to print the report view out, I simply go to M3 and print the report icon. Now I've completed my program, I'm going to go to the M3 icon. I'm going to save my program, and I'm going to save it as demo. Hit save. This program already exists, so I'm going to replace it. And then I'm going to hit the play button. Now it's waiting for me to place that keyway in the screen. Push any button. And now it wants to move in fully automatic mode to do the rest of the measurements. And our program is complete. I can now hit rerun, and it's now asking me if a part is in the same approximate location. I'm going to say no, and I'm going to take the part off the machine, and I'm going to put the part back on the machine at a slightly different angle. Show it where the keyway is. Proceed with playback. And the program is complete. I'm going to hit exit now, and I'm going to recreate the program again, but this time I'm going to create everything from CAD. To start off with, I put the part back straight on the machine, and then after I've got the part back straight on the machine, I'm going to go to the M3 icon, and I'm going to open up the CAD file which I wish to program from. To do this, I click M3 as I just did, open, but then I change to DXF. And this is the DXF file I wish to import. I simply click open. My units are millimeters. I hit done. It's now completing the import. And the first thing I want to do is remove the features that I don't wish to measure. So I'm going to go into multiple select mode. I'm going to delete everything here at the top. Click delete. I'm going to delete this little area here. Delete this rounded slot. I'm going to also delete this slot too. And I'm going to leave everything else as is. Next, I tell it which line I'm skewing from. And then I tell it which line I'm going to make 0 across the x-axis. After this is done, I simply go to Run. I've already got the reduced effective FOV, field of view size, reduced by 35%. Indent from the feature ends is 5%, so it's going to indent on each feature end 5%. In other words, it's only going to measure the middle 90% of each line, for instance, and the maximum number of points per line is going to be 360. To complete this, I say done, and the system moves along and generates a program path for me. Next, I need to measure the bottom of the part. Push done. And then it wants me to measure the left hand side of the part. And push done. Now it's going to proceed in fully automatic mode and measure the rest of the part for me. And after the program is complete, I can click rerun. Yes, it's in the exact or the approximate same position. Proceed. And the program is complete. At this stage, I can hit edit and I can import the nominal information from the DXF file for my report and create the report. This concludes the demonstration of a Falcon CNC machine with M3 software.